name is Denise Shushk, and this is my third year participating in the Wisconsin Science Festival. Today, I'm going to do a demonstration of the milk dish soap experiment, sometimes called milk fireworks. So I have a little story about me as a kid that I think really shows why I'm still so excited about science and learning and just being curious about all of the things this event is all about. According to my mom, one of my very first words when I started talking was, "Why?" And it's funny, but why is still a question I ask a lot, along with what and how and a lot of other questions. So what does this have to do with science? Well, asking those why and how and what questions when we are thinking about science, especially when we are working on an experiment like we are going to do today, is how we learn new things, and those questions also help us think about what we are observing or seeing, because observation is an important part of any experiment. Those questions are also how we can turn a demonstration, or just showing someone a cool activity, which is fun too, into a real experiment, where we think of how different variables, and variable is a word that means something that can change, might also change the outcome of our experiment, or what we see happening in our experiment. Before starting this activity, please get permission from a responsible adult. You can stop the video for a minute and grab your responsible adult. They may want to participate too. Okay, welcome back. Let's get started. One of the great things about this activity is that it is very easy to observe or see the changes that will occur, and it also uses very simple ingredients. All you need is liquid dish soap, milk, and for this demonstration I'm using 2% fat or whole milk, which will work best, and we'll talk a bit more about why that is when we get into our experiment phase. Food coloring. More than one color is great, but it will also work with one color. You also want to use a shallow plate or dish. To really be able to see how our experiment is working, it is better to have a flatter, wider surface, so the plate will work better than a bowl. I'm using a pie plate, but any plate should work. I will say that a paper plate is probably not the best choice, as it could get pretty messy. So here is our list of ingredients again. I'll pause for a minute so you can collect your supplies. Welcome back. Ready to get started? The first thing we're going to do is pour our milk into our plate. You don't need a lot of milk, but it should cover the bottom of the plate. I measured mine ahead of time, and it is about a half a cup. Next, we want to add our food coloring. I'm going to add a few different colors to mine. So while we're adding our food coloring, I have a question for you. Why do you think the food coloring stays on top of the milk? Any ideas? And you can add yours in any pattern you'd like. Have fun, be creative. So I'll give you a hint. Remember when I said we should use 2% fat or whole fat milk for the demonstration? The reason the food coloring floats is because food coloring is less dense or heavy than the milk. The milk we are using has fat molecules, so the food coloring is suspended or floats on top of the milk. A molecule is a group of two or more atoms that bond together and are the smallest physical unit of a compound like milk. Milk has fat molecules, and it also has water molecules. So we're ready for our third and last step. That was quick, right? Very carefully add a drop of the liquid dish soap to the center of your plate. And here's a what question for you. What happens? Ready? Wow, it moves. Cool. So how about another why? Why do you think this is happening? Let's go back to our idea of fat molecules in milk. The soap breaks up those molecules. Have you ever had a really greasy pan to clean, maybe from lasagna or something like that? How are you able to get it clean? The dish soap breaks up the fat molecules in the milk and separates them from the water molecules, and eventually the fat molecules dissolve. This is how the pan gets clean, and it is also how adding the dish soap creates the movement that you saw. Pretty cool, right? Now it's your turn to think of variables or changes you can make to this demonstration to create your very own experiment. Here are a few things I have come up with. Ask yourself all of those why, what, and how questions to come up with your own ideas. So variables to consider. Type of milk. Think about the fat content. Remember, we used 2% fat milk for our demonstration. Will it work with liquids other than milk? Again, think kind of about the fat content that might be in other liquids. Will another cleaning agent besides dish soap work? And make sure it would probably still need to be a liquid cleaning agent. Does the amount of one ingredient added, more or less, to the experiment change the outcome? Or try adding dish soap with a cotton swab instead of dropping the dish soap in. That was another demonstration that I found. I decided to do it by dropping it in, but you can try it the other way as well and see if you get a different result. One very important thing to keep in mind with variables is that you only want to introduce or try one new variable each time. Let's say you want to experiment with different kinds of milk. You would still use the same plate, the same food coloring, and the same amount of dish soap, but choose a different type of milk than you used for our demonstration. If you try too many variables at the same time and something does change, you won't know which variable is causing that change. And remember, there may not be a change, and that's okay too. Experimenting is all about trying different things and seeing what happens. Thank you for joining me today with Try It at Home at the Wisconsin Science Festival. I hope you had fun. Bye-bye.